All right, welcome back, fifth graders. It is Mr. Mace one more time. It is Unit 5, Lesson 5, starting on page 222 in your workbook. And today is literally just a practice day. I mean, you can see it at the top of this page, practice dividing. So I'm not going to go through all the problems on the page because there are a bunch of them here, but I am going to go through the first couple here just to really reinforce the process. Now, the positive with long division, guys, is the process does not change. Whether it's a single digit divisor, whether it's a double digit divisor, whether it's got decimals in it, it doesn't have decimals in it, the process is still the same. But I always encourage my students to write on their page somewhere divide, multiply, subtract, bring down, or does McDonald's sell burgers or does McDonald's sell cheeseburgers, just as a visual reminder so that we can see what comes next in that process. And I know sometimes it seems, I know this, Mr. Mace, but you'd be surprised at how many times we forget one tiny step. And with long division like this, guys, you really need that visual reminder. You really need to make sure you get everything right, because there's nothing worse than doing 99% of the task correctly and then getting the answer wrong because you missed one small step. So please, please, please write that on the side of your board, and please make sure that you are showing your work. These are not mental math problems. I would not expect anybody to be able to do these problems mentally. So I'm just going to go through the first three problems, and the reason I'm going through those first three is they have three different things about them. Problem number one is just a straight 3-digit by 1-digit dividing problem. Problem two is a 4-digit divided by 2, but showing you the process is the same. 3 goes back to a 3 by 1, but it does end up with a remainder. So I want to show you, in this case, we're not worrying about what to do with the remainder. We're simply leaving it remainder whatever. Okay, whatever that remainder ends up being, we're not changing the remainder into anything else. All right, I am going to rewrite the problem next to it just so I feel like I have enough space to do my work. That, again, is another major problem that people run into when doing long division, is they're trying to squeeze it into too small of a space, or they're not lining things up properly, and it makes for some silly mistakes. So, problem number one, 6. The dividing step, 6 cannot go into 5. So if you choose to write the 0 on top of the 5 to keep that order in mind for you, that's great. If you don't, if you are able to get past that step and go right into the 54, I am fine with that as well. It doesn't matter. Everybody is at the same or not at the same point with this. So if you put the 0 on top of the 5, not going to change your answer. Okay, but I am going 6 into 54 right away. Lucky for us, right out of the bat, that is a division fact. 6 can go into 54 9 times, nice and even. So the division is, the D step is 9 times. Multiply step, the number I just put on top of the 4 there, times the 6 out front gets us back to 54. Subtraction step means I've got nothing left over, and I bring down the next number. So like I said, this is a nice and easy problem. Everything goes in nice and easy. No remainders. 6 goes into 6 one time. 1 times 6 is 6. Subtract. Nothing left over. Nothing else to bring down. My answer for number 1 should be 91. Now, if you are able to do that process, guys, you should be able to answer every single problem on this page. Right? The math might be a little harder. We might not be dividing by a single digit number, but the process does not change. So let's jump to number 2, where we have 43 as our divisor, a 2-digit divisor. Can 43 go into 1? Let me rewrite it here just to give myself some space. 43 into 1, 6, 3, and 4. Can 43 go into 1? No, it can't. So I'll put the 0 up there just to placehold it for me. 43 also cannot go into 16. So I've got 2 zeros on top of this one. All right, so I'm going 43 right into 163 from the beginning. So again, in my mind, I'm going to round that number to 40. I'm not going to physically change it. I'm just going to think about it. And I'm going to skip count by my 40s. 40, 80, 120, that's probably where I'm going to run out, because if I go to 160, I round it down, that means I'm probably going to end up a little bit bigger, so I'm going to stay with 3 for right now. 3 times 3 is 9, 3 times 4 is 12, so I'm at 129. All right, that was my multiplication step. My subtraction step, divide, multiply, I'm to the subtraction step. Can't take 9 away from 3, so I go next door and make this a 5. Make this a 13. 13 minus 9 is 4. 5 minus 2 is 3. Perfect. I worked out nice and easily. I don't have a didn't make a mistake. My remainder is smaller than my number I divided by, so I can bring down the next number. So now I got to go 43 into 344. And again, not an easy one to do, but if I think about 40 instead of 43, and I think about 40 times, let's say, 8. 40 times 8 would be 320. Okay, so that's going to get me pretty close. Okay, but maybe I want to try that off to the side. So let's go 43 times 8 just to see if it works. Okay, go through the process here. 4 times 8 is 32, plus the 2 more is 34. Oh man, again, how lucky can we be that it actually goes in evenly? So our answer here is 8. The multiplication step, which I've already done over here on the side, that's one of the reasons that I like to do it on the side, is it does the work for me. I'm kind of moving ahead a step. Then I subtract, and again, I'm left with no remainder. So my answer for that one is 38 with no remainder. All right, and the last one I'm going to do on this page, guys, is question number 3, and that is, again, a 3-digit divided by a 1-digit. Process does not change. Can 5 go into 4? Let me rewrite it here on the side again. Give myself some more room. 5 can't go into 4. So again, I can put the 0 placeholder, or I can automatically go right into 42. 5 goes into 42 8 times. Multiply, subtract. 2 is less than 5. I'm doing everything the way I should. Bring down the next number. Now, I'm looking at this saying 5 can go into 23 how many times? Well, I know my 5's facts pretty well. So 5 goes into 23 4 times. 4 times 5 is 20. Subtract gets me a 3. Now, like I just got done saying at the beginning of this video, we are not going to do anything fancy with it. I could turn that into a fraction. I could turn it into a decimal. I could forget. No, we are just going to say leave it as a remainder for right now. So in this case, my answer for this one would be 84 remainder 3. All right? Guys, I'm going to suggest, especially if this is a struggle for you, practice the rest of this page. Go into it. I've given you 3 examples. That should be enough to get you by the process at least. And then again, check your answer with a parent, check your answer with your teacher, whatever you need to do. I do want to move ahead to the next page here to go through just a couple of problems here in terms of how do we determine what to do in a story problem, or what kind of problems are we looking at here. And this is where the remainder piece does come in a little bit more, where we need to be thinking about what do I do in these scenarios. So I'm going to jump down here a little bit just so I'm not going in order and I'm not hitting some that are a little less relevant to us. So if I'm going to look at problem number 16, it says students in the marching band sold calendars to raise money for new uniforms. Violet sold 24 calendars for a total of $186. How much did each calendar cost? We need to know the exact cost. We don't need to know the rounded cost. We don't need to know about how much it costs. We need to find the exact answer, and we are talking money here, which means we're going to need to do something with that remainder. We're going to need to turn that remainder into a decimal because we're dealing with money. So I'm going to rewrite it over here. 186 divided by 24 calendars. Okay. Now, 24 can't go into 1, 24 can't go into 18, but 24 can go into 186. So again, whether I'm thinking of 24 or 25, I like skip counting by 25s. I think of quarters, it makes it pretty easy. But if I'm thinking about it in terms of quarters, that means 25, 50, 75, 100. 125, 150, 175. That's probably where I'm going to end up, and that's about a 7. Okay? So I'm going to try 7 up here. So 24 times 7. Walking through the process. 7 times 2 is 14, plus 2 more is 168. Okay? Subtract. Have to borrow here. Make this an 8. At 18. So again, I'm all in good shape. I do have some money or have some number left over here, but we need to know how much is in each calendar, not about how much. So that means it's money. I want to deal with decimals, and I'm going to add a 0 placeholder, and I'm going to bring it down. That does not change my number at all. Okay, it doesn't change what I'm working with here. So now how many times does 24 go into 180? Well, if it went into 186 7 times and it's still 168 for my answer, that kind of works out nice for me. I can know already that it's a 7. Okay, and this answer is going to be the same when I multiply because it's still just 7. So now I'm to the subtraction step here, and instead of having an 18, now I've got a 12. Again, still have a remainder, so I'm going to add another 0. Now this time again works out a little nicely for us. We can say how many times does 24 go into 120? Well, it's going to end up ending for us right here because 24 does go in evenly to 120 and it goes in 5 times. I can prove that by saying 24 times 5 gets me to, not subtract 5, times 5 gets me to 120. There's my answer there. So 120 when I multiply, subtract, I'm done with my remainder. So the answer to problem number 16 is $7.75. We do not want to leave that answer as $7 remainder 18. We need to turn that remainder into a decimal because we're talking about money and they're looking for an exact answer. Another time when that's going to matter, another different kind of question we're going to look for is the one that's talking about the thumb drives. Question number 18 here says, Ayala has 655 computer files she wants to put on thumb drives. If she can fit 18 files on each thumb drive, how many thumb drives will she need? So the first thing I need to think about is what am I going to do if there is a remainder? Okay. Does she want to save all of her files, or is she fine with leaving some of her files off of the thumb drives? It seems to me like she wants to save all of her files, which means that we are going to need, if we have a remainder, to round up and use one more thumb drive. So let's go through the process and see what we are looking at here. 18 files per thumb drive, 655, so 655 divided by 18. Well, 18 cannot go into 6. 18 can go into 65. Looks to me, like 3 times. 18 times 3 is 54. Looks pretty good on that end. Subtract just to make sure. Remainder of 11. That's still good. 11 is less than 18. I'm on track. Excuse me. I should have done this before. Divide, multiply, subtract, bring down. Bring down my next number. Now, how many times does 18 go into 115? Okay, again, not quite sure, but if I think of 18 as 20, 40, 60, 80, 100, I don't know that I can get another one in there, but I'm going to try a 6 anyway just to see if it works. 18 times 6 gets me to 108. Oh, it looks like it fits underneath there. That's good. Now, what did we say we wanted to do with that remainder? Is she going to leave 7 files off of the thumb drives? No. In this case, we would want to round that up. So she's going to need one more thumb drive than the 36 that she had. 36 will get her most of her files, but not all of them. So in this case, that remainder is going to tell us to round up to 37 thumb drives. All right. So again, guys, I will give you the same direction I gave you on the last page. If this is something you are not extremely comfortable with, if this is something that you are struggling with, okay, what do I do with this remainder? What is this story problem trying to tell me? Please ask your teacher, practice the rest of the page, check your answers with your parents, check with your teacher. Maybe even use a calculator. If your answer is going to end up being a decimal, I'm fine with that as well. But again, the key here, guys, is practice. Today is a practice day. Your exit ticket, which you'll go to next, will be strictly just practicing the same types of problems we did in this video. All right, good luck. Don't forget to ask questions if you have some. Again, this is not a quick process, guys. We know that these problems will take us a little longer, but we do know that the process at least is the same, no matter if it's a single-digit divisor, a double-digit divisor, if there's a remainder, if there's not, and those kinds of things. Good luck.